Hello dear friends and welcome to another electronics video. So today we are going to solve this week's operational amplifier challenge. So we had to build four circuits. The first one, it's a non-inverting with an amplification of 10 and a dual supply. Second one, it's an inverting 5 amplification dual supply, non-inverting amplification of 4 single supply, and an inverting with amplification of 3 single supply. Great. So first of all, before we get started, I would like to go a bit back to our chosen operational amplifier. So just having a bit of a look over the data sheet for the LM741 from Texas Instruments. Um, this component seems to have a better option. So this is the TLV9301, which seems to be the newer version for the operational amplifier. So let us use this component for our designs, just that we use the most recent and best component that we have available on the market. So it looks like this. It has a 5-pin um, design, and let's start by first getting the model for it, and then let's add it to our LT Spice library. So to get the model, going here at design and development, design tools and simulation, you can find the TLV9302 Spice model. Let us download this and let us copy everything that is here. I have a personal space on my E drive where I save these, so there's LT Spice components. I already built it once, but I'm going to do it again. So this is the TLV9301. I'm going to put a /2 on my side because I already built this component. And now let's open the library file and create the symbol in LT Spice. Okay, so we're going to open LT Spice, going to File, Open. We're going to take the design from where we have saved it, and we are going to select all files, select the library file here, click open, and here we have the Spice description for the component. Okay, so let's create the component. So we have here create symbol, and LT Spice asks, do you wish to automatically create a symbol that will net list against the subcircuit? Of course we want to do. If we want to overwrite, yes, so we are going to click yes to overwrite it. Okay, in my case, so this would be the component. Let us delete the square, which is not the symbol that we would like for an operational amplifier. And let's move a bit the pins here. So the VCC would be on this side, output would be here, and would be here. And let us draw the operational amplifier symbol. So right click and go to draw a line. And here we can start from this point here. Like this is 1, 2, 3 points above. Click it in the middle of the pins, and then go another 1, 2, 3 down, and then connect it to the output, and then going back to the starting point. Great. Okay. These don't look quite well because they're overlapping, so I'm going to right click on the pin, and you get the pin port properties, and here we can put them on the left side. So on the left side or right side. on the left side. Let's see if it's not moving the component. Okay, so I want it on the left. Okay, and let's move it back. And for this one, we want it also on the left side, and this moved automatically. And also the out pin. Yeah, we can keep it this way. It's okay. We can see the difference. Okay. The next thing we have to do is we have to draw the lines for the supply from the supply pin to here where we have the connections. So, okay, maybe I should zoom in a bit more to make it look better. Okay, I'm going to delete this and put it again. Yeah, draw a line from this pin to here. Okay, and from this pin, so I'm going to go draw a line from this pin to here. Okay, so our circuit looks really good. Let us start by looking how this component is looking in the library, in the circuit. If you would like to do the challenge for yourself, now is the time. My next step is to go and to build these four schematics. So let's go and build a new schematic. And here let's place our center component LM TLV. It's the TLV9302. So we're going to place it here. Okay, so no overlapping. It looks good as a component in the schematic. Great. Now we have to look a bit at the challenge. So first one, it's a non-inverting 10 amplification dual supply. Great. So now we are ready to start building our schematic. We can go here, we can select a voltage source, another voltage source, and we can place the ground between them to create the differential power supplies. And then let's connect everything together. Okay, so then we have the V1 would be the positive supply. Let's put 15 volts here with a DC resistance of 0.05 ohms, and then the other one, same 15 volts with a internal resistance of 0.05 ohm. Great. Now we have placed the supplies. Now all we have to do is create the circuit so that this would have a non-inverting amplification 10 circuit. Okay, so for the non-inverting, going back, so non-inverting applications, the amplification is 1 plus R feedback RF over RG. So we have to have the amplification 10. This means that RF divided by RG has to be 9. So we need the voltage, this division to be equal to 9. Okay. So first of all, let's put our signal generator. So the signal generator will generate a sine wave. No offset, only 1 volt, let's say, amplitude, so it would amplify this 10 times. And for frequency, let's put 20 kilohertz just to see how the system functions. Okay, let me move this a bit to the left. Let's connect the power supply. So we are just connecting the power supply now to the non-inverting pin. The next step would be to connect also the supplies for the operational amplifier. So this is the 15 volt supply and the minus 15 volt supply. Okay, let me connect this here And let's cut off this little part here. Yes, that it looks much better. Okay, and last step, we have to create the feedback network. So we need a resistor and a resistor that is 9 times bigger. So let's go with a resistor of 10 kilo ohm and a resistor maybe 9, it has to be 9 times higher. So let's put like a 90 kilo ohm resistor that the division between them is 9. Okay, 10 and 90 kilo ohms. Great. And let us connect everything together. So this is the feedback network and ground for the feedback network. Okay. And the circuit seems to be ready. Okay, let's see what LT Spice says about our circuit. It says that we need to set the stop time, which is like 10 milliseconds. And let's see how this works. Okay, so I have these two windows that we don't actually need. Okay, and let's see how this looks. So here is the output signal, which is 10 volts to 10 volts, and first we have to check if um, it's okay. Yes, one goes up, the other one goes up as well, so it's non-inverting amplification. So first challenge is done. We have created a non-inverting operational amplifier with amplification of 10 and a dual supply. Great. Let's start on the next circuit. So next circuit is a inverting amplification 5 dual supply. Okay, so we need to invert the sine wave. So when this goes up, the output has to go down. So here we can see this is the output which is amplified, and this is the input which is smaller. Okay, so then let us copy everything. So you can copy a piece of the circuit with Control C. You see a cursor changes to this copy icon, and then you just have to select what part of the circuit you want to copy. So we're going to copy everything here. Okay, great. So now what we have to do is change the circuit from a um, non-inverting operational amplifier to a inverting operational amplifier. Okay, so the inverting operational amplifier has the non-inverting pin is connected to ground, and the signal is supplied to the inverting pin. Okay, and the amplification is the feedback resistor divided by the input resistor here. So if we want to have an amplification of 5, we need that this division here to be 5. So we can take, for example, 10 kilo ohm and 50 kilo ohm resistor for the feedback. Okay, so let us delete these connections here just to simplify a bit our design. Okay, first step is we have to connect the non-inverting pin to ground. So let's take the non-inverting pin here and let's connect it to ground, and this is done quite fast. Okay, let me also delete this very small line here so I want to move the power supply a bit, the signal supply a bit lower so that we don't have this winding of the traces. Okay, so this means that we from the signal generator we need one resistor, a 10 kilo ohm resistor, to go to the to the inverting input, and then um, for the feedback network I'm going to place it here just that I don't overlap this line. So I'm going to connect this way. Okay, this has to be a bit higher here. Okay, so first resistor going into the inverting input has been connected, and the feedback resistor, we have to place it in the same place. Okay, and we need an amplification of 5 here. Okay, so then we are going to put 50 kilo 50 kilo ohms, so that we get a final amplification of 5 here. Okay, let us run the simulation. Okay, I don't know what we're measuring here. Let us see the signal and let us delete all other traces. So we can see here that for a 1 volt amplitude input, so this is the input signal, we get a much higher output signal, 5 times higher than the input signal here. And also we can see it's inverting because this is going up and the output signal is going down. Great, so we've solved quite fast the first two circuits. Next, we have the first tricky circuit. It's a non-inverting amplification of 4 single supply. So going back a bit to our previous video, so the single supply here, it's very similar to the previous with the dual supply design, but it has this capacitor here so that you have a stable voltage level on this inverting pin that goes into the operational amplifier. Okay, so we need to create the circuit. The amplification has to be 4, but we know from this the circuit from the previous designs that exactly from here we know that the non-inverting amplifier has the amplification of 1 plus R feedback divided by RG. So this means that R feedback has to be, the division between these two parts has to be equal to 3, because 3 plus 1 equals our 4 amplification. Okay, so going back to LT Spice, I'm going to copy this whole circuit. So Control C, select the area of the circuit that I want to copy, and then I'm going to paste it here. Okay, let's start with a bit of cleanup. So I'm going to delete the secondary power supply because everything is here, the VEE has to be connected to ground in this case, because we have only one supply and the lowest voltage level is the ground. Okay, let's do a bit of tailoring here so that it looks a bit better. Okay, and place this here, the ground for the power supply. And now we want to do a non-inverting circuit. So I'm going to delete this. I'm going to keep the resistor because we still need a 10 kilo ohm resistor here, but I'm just going to place it below because this is going to go to the capacitor that will hold this voltage level at half of the supply here. So we're going to connect the sine wave through a capacitor to for a half of the supply voltage line. So I'm going to take this capacitor, rotate it here, change the value. Let's put a 10 micro farad capacitor here, and now we have a sine wave. We have a capacitor that will remove any DC value from the signal generator, and all we have to do is raise this signal on a DC voltage, which has to be half of the supply. So how do we raise a signal? As we discussed in the operational amplifier um, video, we're going to use a voltage divider here, and we are going to divide this voltage in two. So it's going to be a 10 kilo ohm and also a 10 kilo ohm resistor that will divide the value from the supply into two values. For more details how you create a voltage divider, we also have a voltage divider video where you can find more information about resistors and how they behave in circuits and different topologies. Okay, so what we have managed to do till now, we have taken a 1 volt sine wave, we have pushed it through a 10 microfarad capacitor into a DC voltage, which is half of the supply, and we are really good on the on the inverting input side. Okay, all we need now is to stabilize this operational amplifier and to set the gain for it. So let us rotate this resistor here, rotate it. Okay, and our amplification, as we said, is 1 plus the division between these two resistors. So R6 has to be 30 kilo ohms, because we need to have an final amplification of 4 here. Okay, last step is the capacitor, the filtering capacitor that has to be placed here. For a value, I recommend 100 microfarads. It's quite good value to filter the DC voltage. Okay. Great. So let us review. We are taking a sine wave, pushing it through a 10 micro farad capacitor, pushing it through 7.5 volts, a voltage divider that raises the voltage levels to 7.5. Then we are going into the non-inverting input, and then in the inverting input we have a 30 kilo ohm feedback resistor, a 10 kilo ohm resistor to ground, and a 100 micro farad capacitor. So this looks great. Let us run the simulation and see how the circuit looks. Okay, let me delete the previous two traces. Okay, so this is the output value here and the input value here. So let's have a look. We have set an amplification of 4. So this is taking a 1 volt peak to peak, and now we have from 3.5 to 11.5, somewhere like that. Let us zoom in a bit more. I think I need to zoom out quite well. Let's go a bit back, zoom to fit, and let's go a bit more precise here. Okay, so it's 11.5 to 3.5. So if we take a calculator, 11.5 minus 3.5, we get about 8 volts, and this is a 2 volt. The input signal is 2 volts peak to peak. So then we get a 4 volt amplification for the signal, and also this is a also the inputs the amplification is also non-inverting. So the input goes high, the output goes high. When the input goes low, the output goes low. Okay. So this is the non-inverting amplification for single supply, and challenge number 4, and the most challenging of the circuit, is the inverting amplification 3 single supply. So we need first to go a bit to the inverting circuit. So here for the inverting circuit, the amplification for the circuit is R feedback divided by Rn. So this means that we need, if we're fixing Rn as we did before at 10 kilo ohm, the feedback resistor has to be about 30 kilo ohms. Okay, so let's start the circuit. I'm going to copy the circuit. This is quite close to what we want to design. So Control C, we get the little icon with the copy. We drag the line and then we push it and create a new circuit here. Okay, great. So first of all, let us delete these lines here, because the signal is going to go into the non-inverting input. I'm going to also delete the resistors. Oh, I deleted the signal generator also. Let me copy it back from here. Okay, and we are going to take this input, and then we are going to create the same circuits, the same resistors for the input. So let us copy or move the 10 and 30 kilo ohm resistor here, and then we are going to, the 30 is still going to be the feedback. The 10 has to be placed between the signal generator and the inverting input. And I'm going to rotate it also, just that it's a bit looking a bit nicer. Okay, and I think I have to, yeah, I have to delete this. Okay, and then let's connect this to the non-inverting input, to the inverting input, and the feedback resistor goes also to the inverting input. Great. So going back to our previous design, we can see here that this is connected to ground, or the half level of what we have supplied. Now what we have to do is we have to create this ground layer here. So let us go back to LT Spice, and here we have to create this ground level in which we have to connect this to connect to this non-inverting input. Okay. So this means that we have to create a ground level to the to resistors, let's say 10 kilo ohm, 10 kilo ohm, and we will need also a capacitor in order to have a filtering on this level, because this voltage level has to be half of the voltage level of the power supply. Okay, and I'm going to also connect the capacitor, and yeah, capacitor connected, and all we have to do is connect this line here. This is not looking that great as I hoped, but it is functional. So this line, this voltage level here will go to the non-inverting input to create a voltage level so that the signal can swing around this voltage level. Okay, so let's give it a run and see how the output looks. So we're just running this. Okay, and I see that the circuit is taking a quite long time to process this. I'm going to remove some of the traces because we don't need, I'm going to remove all of the traces just to make sure that we don't have any issues here. Okay, I see this takes a very long time to simulate. Okay, but we can see that this is the output signal and the input signal here is okay, this is the signal from the signal generator. Let's take the one going into the operational amplifier. Let's go zoom to fit. Okay, we can see that the signal is quite small on the input here, but it is amplified. I'm going to actually remove this so that we can measure the signal out of the signal generator. So this is 1 volt, and here on the output we have 7.5 till 4.5. So this means that we will get 7.5 divided by 4.5. This 7.5 minus 4.5, so we have about 6 volts. So this divided by 2 volts input voltage, we get the amplification of 3. Okay, so this is the circuit for the non-inverting operational amplifier, and this concludes the final schematic for the project. Hope you enjoyed this challenge to create four designs for different operational amplifiers. And if you enjoyed this video, please subscribe and like this video, and wish everybody a great day. Thank you.